Okay, 13.3. So now we get into these rules of exponents, which I've taught it so many times at so many different levels that like it's just about practice. You have to see a ton of examples to get the hang of it. So I added some examples there. The product rule means that whenever two terms with the same base, or remember variable, are multiplied, it's going to turn into adding the exponents. Okay, so x to the third times x to the fifth. It's the same variable. It will become x to the eighth. And you're done. But compare that with if I had something like 3 times 5x. Now that would be 15x. So like I'm multiplying the coefficients there. But it's a different ballgame when you're talking about the exponents. Look at the one on the right. X to the third times y to the fourth times x to the fifth. You don't even need to put the dots either. We can assume it's multiplication. X to the third, y to the fourth, x to the fifth. We cannot combine the y and the x. So now we have to leave this as x to the eighth, y to the fourth. You can't do anything with the y.
But you can only do it with variables, right?
Correct. How about 3x to the fourth, x to the third? Yeah, because again, if you really want to get technical, you can assume that there's like a 1 in front of that x. So 3 times 1 is just 3. But the computer in the textbooks will never do that. It'll just say 3x to the 7th. Which leads me to the next one. How about 4x to the third times 5x? (20x to the fourth). Because there's a hidden 1. So you say to yourself 3 plus 1, right? I don't know if this will help some people or not, but what if I write the whole thing out like this? Because it's x to the third. There's 3 x's, and then there's, so how many x's are there? Right, 4. If you really wanted to write everything out, that's what you could do. Negative 3x to the third x to the fourth times 2x. So now the problems will give you like multiple things. Almost, you're missing one thing. Yeah. Negative 3 times 2 is negative 6. And then I have x to the third, x to the fourth, x. So that's 1, 2, 3, 4, 5, 6, 7, 8. Negative 6x to the 8th. You get the hang of it. You don't really need to write much work at all. Five x squared times 3y times 2y to the fourth. Shot.
X squared times 6y to the fifth.
Almost. You can do one more thing.
Oh, I have to add them, right? 7?
Multiple.
Or no, multiply.
No, you can't. You got to leave the exponents alone because it's 2 and 5, and it's an x and a y. So leave the exponents. But what can I do with the 5 and the 6? Yeah. So you can still just multiply all the numbers. Right. Very good. I mean, maybe I should have put y to the fifth first, but because it's a higher degree, but it doesn't matter when it's just one term. Power rule. When it's power to a power, then the exponents are multiplied. It's only when you see 2 exponents put together. That's my little note for this one. So x to the third taken to the fourth power. 3 times 4. 12. So x to the x to the 12th. Okay, so now I made a note, apply the exponent to everything in the parentheses because there's more than one thing in there. You have an x and y. So it's like distributing, but it's kind of not. Because it's only one term, but you should write x to the 7th, y to the 7th.
You don't have to put the times on there?
No, you do not have to put the dot or the multiplication. Another one that'll do, like this is where you have to remember to apply the exponent to both things. Because this actually becomes 3 to the 3rd power. X to the 2 times 3, 6. But now you have to say to yourself, what's 3 to the 3rd power? 3 times 3 is 9. 27. This would be 27x to the 6th. All right, it gets hard, yeah, but just take it one step at a time. So in the B one there, it'll be 5 to the 3rd, x to the 3rd, and then y to the 4th to the 3rd power. What would that be? Can you tell me? What's 4 times 3? 12. So it's going to be y to the 12th. You're not done yet, though, because now we have to do 5 to the 3rd. Five times 5 times 5. Let's see, 125. So 125, x to the 3rd, y to the 12th. All right, a couple more. Negative 4 times x squared to the 8th power. Your turn. The negative 4 is not part of the parentheses. So don't do negative 4 to the 8th power. All right, just do x squared to the 8th power. So multiply them. Negative 4 x to the 16th power. So here's the difference. Add. Multiply.
How come you won't do like the x and then the exponent?
Which problem are you asking about?
The one thing you just went over.
Here?
Yeah.
Okay, why didn't I do what?
You know how like the one up top you did like the exponent with the 3 and then the exponent with the x to the 2nd power?
Yeah.
Why is it not 8?
Yeah, good question. So I didn't apply to the 8th power to the 4
No, not to the 4, to the x.
to the x.
Yeah.
Oh, I thought I did. Like, The one up top, I did x squared to the third, which is 2 times 3, that's 6. So I just multiply these here. Look, last one we'll do, okay? Look at this one over here, negative 2x to the third. All of it taken to the fourth power. The 4 gets applied to both of them. Kind of like that, right? It's a little complicated, right? So, negative 2 times negative 2 times negative 2 times negative 2. Any ideas?
So it's negative 2 to the fourth, but then it's x to the third to the fourth.
Yeah. So multiply these two together. What's 3 times 4? All right, so we have x to the 12th. The only question is, what do we do with the negative 2 to the fourth power? So you got to do negative 2 times negative 2 times negative 2 times negative 2. Which would be your turn. What is it? Yeah. Negative 2 to the fourth power. The trick of it is whether it's positive or negative. So if I multiplied all those together, it would end up being a positive 16. So that whole thing is positive 16x to the 12th. All right, any questions?